All right, hey there, good afternoon, everyone. Welcome back to class. Good to see you guys. There's 3 minutes still left until we get started, but I'm just starting off the stream for now. So hope you guys have been doing well, and feel free to say hi or anything in that chat whenever, and we'll be getting started in just a bit. Hi, Anthony. Hey there, Peru. Welcome back. Hey, Devin. Good to see you. Matthew, hi there. Just another minute, pretty much. Okay. All right, just a little bit here. Just wait until 12:45. Hey, Jake. And hey there, Con, Austin. Nice, good to see everybody. Okay, well, it's pretty much 12:45 now, so let's just get things underway. Good to see you guys, and nice to be back. First of all, thanks for watching those videos and stuff that I delivered for the Tuesday meeting. We had a quick little two-part meeting or set of meetings, two installments rather, on media, advertising, and marketing. So last Thursday we had a lecture on that, and then there were some videos I wanted to send off so you guys could get a little bit more multimedia involvement in the class. Now we're back. Hey there, Noah, good to see you too, and hi, Jonah. And we have a couple more chapters of the book to finish the class with. Chapter 12, which we'll start on today, that's all about science. And we'll have two meetings on this, today and then Tuesday. Then next Thursday you'll have the last quiz for the course, and that's going to be on chapter 12. So a week from today you'll be taking the third quiz. And there's one more homework assignment that I'll be assigning after this week. Right now you guys are still finishing up the third homework assignment, which has to do with finding fallacies in ads. So don't forget, that's due anytime before the end of the day, Sunday, Sunday night. And we're looking forward after that to one more homework assignment, one more quiz, and the final exam. So that last quiz that we're going to take is a week from today. And then the fourth homework assignment is going to be due on the Thursday of May 20th. And then the final exam is May 27th. Yeah, Paul, maybe you say it's tough to find ads. Here, I can give you some advice. This assignment used to be an in-class group assignment that all the students would work on together. And what I had students do back then was to all bring a magazine, one magazine each, and they would use the magazines together, cutting out ads, compiling them, and in one 85-minute class period, or even in some institutions, 75-minute class period, they will always complete the assignment and get most all the fallacies. So I know that if people can do it with just a set of magazines in 75 or 85 minutes, then you should be able to do it with having over a week. But let me offer you this as advice. Buy a magazine. Go out there, buy Cosmopolitan, Elle, some fashion magazine with like full page glossy print ads, and use that if you have trouble finding it online. Sometimes I think that your online search could also be negatively impacted by how, well, there you go. Yeah, try to look through those magazines and like sort through the physical ones. Because if you have a body of ads that is in front of you and you're not self-directing your search online, sometimes that actually makes it easier, because you can sometimes like get lost online trying to perform the correct search. Because if you just look for a search that says like bad ads or something, it might not be specific enough to reveal like all the different fallacies that we have. And if you're writing in like just fallacious ads, sometimes that'll be a better search item, because it will at least narrow the search to things that have fallacies, but they might not just directly tell you which one it is, so that you still have to give your own thought and insight into it. So, you know, yeah, Super Bowl ads, video ads, commercials on TV, that's one way to do it. But I also think ads that involve images are quite good, because in many of them you're going to see like an accented word that's bolded, or you're going to see a word that's used twice over where it's got equivocation in it. Just one example, okay? I just had a student come to the office hour, and I just helped them do a little bit of Google searching, and just right away we were able to find, for example, like equivocation. There's an ad from PETA which said, stop eating meat, and, you know, do it for chicks. And it's got like this guy holding little baby chickens, but the word chicks is bolded, and so could be equivocation on the term chicks, either meaning like women or, you know, little chickens. Or you could say it's an accent fallacy. So you have a little bit of room for interpretation as long as you justified it the right way. So I would just offer you that as another way of trying to expand your search and find more materials. But I have 100% confidence, Paul, that you can do it, because I know a lot of other people have done it before you. So why can't you do it? You can do it. All right, Noah, there you go. Hopefully you guys can get into that. But good. Thanks for the question, though. So don't forget your homework 3 on fallacies. That's due to me as an email anytime before the end of the weekend, which is midnight at the end of Sunday. And a week from today, it's quiz 3. Then your 4th homework assignment. I'm not going to tell you about it until next week, because I want you to be focused on you know, your current assignment. But on Tuesday, I'll notify you about how to do the next one, and then that'll be due on the 20th. And then the last meeting is Thursday, May 27th, which is the day of the final. So 3 things to do: homework after this one, last quiz, and then final exam. But let's get back into our, you know, material. We have to talk about chapter 12. So let's start. Oh, here's another thing. Before I talk about chapter 12, I just want to put this out there and get it off my mind. Can you believe this? So this was a little bit of a disruption. Sunday night, someone broke into my car. Come on, man. Someone broke into my car where it was parked in its designated spot in an underground parking garage. Somehow, some person, I don't know who, was able to get through the gate, and they saw, I guess, because I had a nice guitar in a hard shell case. We're talking about an American Fender Telecaster guitar. And, you know, like $500 new retail value before tax. Anyway, so they snatched away the hard shell case with the guitar in it, and they broke out the back driver's window, my BMW. But, you know, it's a little annoying, obviously, but I don't know, I dealt with it in stride. I have insurance for everything. So, you know, I have house insurance, renter's insurance, car insurance. So they've already made me a check for the guitar, or at least most of the value of it. It's they gave me $1,320, and it's valued at $1,450. So a little depreciation, but almost the whole replacement cost. And then yeah, so I had insurance on just homeowner's insurance for any items that might get stolen. So I was able to file a claim, and the check's in the mail for that. The other thing, though, is you know, for the car, that's actually the worst situation, because the breaking of the window on the BMW, I have to pay a deductible. So it's going to cost more than the deductible. So most of it's going to be covered by the you know, AAA auto insurance. But I'm taking a bigger loss on the replacement of the window than the guitar. Anyway, though, you know, those things can happen, and I would say this: it's definitely something I'm sure everybody knows, but I guess I have not yet learned my lesson. I guess now I've really learned it. But you're, I guess, supposed to not leave, you know, valuables in a way that could be seen in your car. But my belief was, okay, it's in its designated parking spot. It's in its garage. there's a gated thing that you'd have to use to get in there. So I just figure it's safe enough, and it would have been a hassle for me to kind of carry it up and down, because I go to a studio where I use it with a couple of musicians, and sometimes I just like to leave it in the car for the next time I drive out. But now I know better. And yeah, I'll never leave it in the car again. I'll make sure to bring it in. So that was my weekend. That was kind of a hassle. On Sunday night, I get a call right as I'm about to go to bed. And, well, it wouldn't get warped in this garage because it's, you know, underground and it's pretty cool. But anyway, yeah, point being that I had to deal with that. On Sunday night, I get a call from my neighbor. He's walking down to his car to drive off somewhere, and he calls me. I'm like, who is this? I'm getting ready to go to bed. He's like, oh, hey, it's your next door neighbor, because we have each other's number. And he says, come down to the garage. It looks like someone broke out your car window and took something or whatever. I went down, saw it, filed the police report, and yeah, that's how it happened. But anyway, things can get stolen in this world, so you got to sometimes be a little bit more protective of your items. It's nice that I had insurance, but I've learned a lesson, so I guess I'll pass it on to you. And I see all your guys' comments and stuff. Yeah, leaving gear in your car, not the best smart idea. Of course, people don't have a right to break into your car even if it's unlocked. But you know, that's how it is. What BMW car? Oh, it's a 2018 430i Grand Coupe Black, the red leather interior. Anyway, cool. So just letting you guys know, a little personal aside. Nothing to do with our class though. So yeah, let's get back into this. Chapter 12, everybody, science. All right, so science. As critical thinkers, it's important for us to be able to interpret and understand information that we hear from the scientific community, or in scientific journals, or in media reports that make scientific claims. Let's talk a little bit about some concepts that are mentioned at the beginning of chapter 12 to just bring the student into the topic a little bit. So they talk about at the beginning the idea and the concept of global warming, that according to the most reliable data that we have that tracks like global temperature over the past 150 years, we've seen a significant increase in global temperatures in that time period. And it's caused sea levels to rise by at least 7 inches over the last century. Why does that happen? Well, there are industrial processes that involve the emission of greenhouse gases, carbon emissions and stuff. Those gases can get trapped in Earth's atmosphere, and it causes a greenhouse effect where it causes the planet to warm up just slightly. And the warming trend over time with these greenhouse gases that are trapping in heat, it causes the melting of the Arctic sea ice and parts of the ice shelf. So that's the reason that, you know, global sea levels have have been rising a little bit over the past 100 years. And according to reliable estimates and even some conservative estimates, we could see as much as another foot of sea level rise by the turn of this current century if we didn't do something to mitigate the effect of global warming. In this recent past few decades, the trend has actually accelerated quite a bit, and we've seen the hottest 11 years globally since we started measuring this at all since the year 2000. And some of the hottest years ever recorded have all happened just in the last decade, from 2010 to 2020. And this causes the rising sea levels, which is a scary and concerning thing for people living in coastal regions, because, you know, according to some models, there could be significant devastation or at least environmental impacts that cause harm to property and et cetera on the coasts, like in places where we live. So as critical thinkers, we certainly do want to be able to interpret and evaluate scientific claims and information. In this chapter, we'll learn a little bit about the early history of Western science. That's funny, Noah, yeah. We'll identify certain assumptions that science makes. We'll talk about the various steps of the scientific method. And we'll talk about what are qualities of a good scientific hypothesis or theory, as well as how to tell the difference between like credible science and pseudoscience, or in other words, like fake junk science. So as with other chapters in the book that took on like major topics, whether it was language or knowledge or something, it's good to establish a set definition of the basic topic or concept at the beginning. So like with language, we say system of communication that involves a set of symbols, whether they be spoken, written, or nonverbal. Then you've got knowledge, justified true belief. A person believes something which is true and for which they have got justification. Well, what is science really in the general idea of the term? So what better way to start than with the definition of the main topic, science. In science, it's reasoning from observable facts to testable explanations for those facts. Okay, so with science, we have a process of reasoning, which begins with observing just facts, what is happening. We collect these facts, and then we try to eventually establish testable explanations for them. So in science, it's really the business of trying to explain why things happen, or cause and effect relationships. Imagine that you're like a primitive person living, you know, in the ancient times, before we really had too much scientific comprehension of the world. And in this pre-modern part of world history, a volcano erupts. Now, they would be able to observe that, but they wouldn't have, let's say, the scientific explanation for why it happens. Like in the Earth's core, there's magma that collects and pressure that builds. Or if a person saw a bolt of lightning, they would not know that that is like a discharge of electrical energy because of water ions in the Earth's atmosphere, which is the scientific and physical account of what it is. So in science, we want to actually understand why things happen. Why does the solar eclipse happen? Why does the earthquake happen? How is it that plants are able to convert light into fuel for food and energy? Before the scientific explanation exists, people just have mysteries. Things happen and they don't understand why or how. So then they cannot prepare for them. They cannot mitigate things if they're not desired. They cannot replicate things if they're desired and in a person's interest. So science gives us power because once we know how things work, we can control them a little bit better. And that's how we develop technology. That's the reason that we have computing systems, telecommunication systems, transportation systems, energy production. It's all because we look at this world that we just appear on and try and understand what its properties are, how things work, and what cause-effect relationships hold between things in physical space and time. So science, as you guys, I think, understand, is the major primary source and method for gaining knowledge about anything in this world. If there's a question that you have, how does something work? Why does that happen? Why does it do that? Then science would be the best place for you to look for an answer, because science is time-tested, it's based on empirical data, so it's not just wild assumptions that people throw out there off the top of their head or speculation. Scientific claims, I mean, even though they can, of course, be refuted if enough available evidence comes in to contradict them, they're our best approach to the truth and to understanding why things work and how they work. So we should have, I think, a heavy dose of respect for science, but the growth of the scientific community and its influence on our world, it's kind of been a slow, steady march towards our current day modern norm. If you go back in history in the West, the primary source of all human knowledge and learning would have been considered the church, way up until, you know, the later period of the medieval era and the Renaissance. Especially the 16th and 17th century, we start to see kind of like a breakthrough where science starts to emerge as a greater force in the world, and where it starts to gain some independence from the more dominant role that the church had before that. So there's some actual interesting figures in the early history of Western science that the book mentions, and just to tap into what some of those people are and what they did, we'll add them to our notes. So one important person was Nicholas Copernicus. So as it says here in the book, here's the name anyway, Nicholas. That's the spelling. Copernicus. Okay, so who was Nicholas Copernicus? Well, he lived from 1473 until 1543. And he was a Polish astronomer who made an important, somewhat revolutionary discovery in the sense of the history of science. So, Polish astronomer who discovered the heliocentric model of the solar system which replaced geocentrism, which was the older paradigm that existed before his work, and also the work of Galileo. So, Polish astronomer discovered heliocentric model, discovered heliocentrism, which replaced geocentrism. Now, just a question. Let's see if you have a sense of this. I don't know if it's already knowledge in your mind or if you could just deduce it from the terms being used here. But what do you believe, in other words, was Copernicus's big discovery? I mean, so like newly invented telescopes were coming into use around this time, and that meant that people were able to conduct more precise observations of the motions and orbits of the celestial bodies in our local cosmos. And he did discover something important, which is heliocentrism. What do you think that is? Heliocentrism. What could that mean? Let me hear. Devin. Yes, that's correct. So the idea, or really the discovery, is that the sun is at the center of our local cosmos, at the center of the solar system, instead of the Earth being the center. Correct. So helio refers to the sun. Centric, meaning centered, placed at the middle. So heliocentric model is that the sun is at the center point and we rotate around it along with the other planets. Prior to his discovery, and also Galileo is another important figure who's responsible for the same discovery. Before that, it was assumed that the Earth was at the center of it all. Geocentrism, Earth-centered. And it might not seem like, what's the big deal? Yeah, the sun's at the middle. Everyone knows that. That's what we say today. But back then, this was quite controversial, actually, and it was even considered by the church to be heretical because it would have been regarded as unorthodox. See, there was a reason that they had the view that the Earth was at the middle, because it was out of deference to the church. The orthodox view at the time was that God's the creator of this universe, of course, and if he's the creator and he creates us in his image, then he would have wanted mankind to occupy a sort of privileged position, a central position, in which everything revolves around. In fact, the discovery of heliocentrism was considered so offensive to the doctrine of the church at the time that Galileo, for example, was threatened with execution if he didn't publicly recant his testimony. And so even though he was up in his 70s, halfway blind, but from looking at the sun through telescopes too much, they thought of him as a subversive figure. So they say, you got to go out in public and tell everyone, I don't know what was wrong, sorry, I was possessed with the devil or something, just kidding, the Earth's at the middle, I don't know what I was saying before. And he did have to recant his testimony. I don't know, Copernicus, I guess, was spared, but Galileo, suffered some sort of serious persecution. Anyway, in the centuries that have passed, it's become unambiguously acknowledged by everybody that the sun is at the center of our local solar system, and we have way more precise ways of determining that now. So the church has apologized since then to Galileo and even his descendants for the persecution he endured at the time. Now he's kind of like a towering figure in the history of science. But that's an important discovery, and in some people's view, this simple discovery that the Earth was at the center set off a revolutionary tidal wave of scientific exploration, and it kind of showed that through observation, using actual tools of observation that we can develop, that we can discover things that run contrary to established traditional thinking. And that gave a sphere of independence to scientific research that didn't really exist before. After that, as we get into like the 1600s, we see like an explosion of secular and scientific knowledge. People are discovering facts about calculus, geometry, Newton's laws, the facts about anatomy, the cellular construction of biological material. So Copernicus's discovery, as much as it may seem as a casual afterthought today, why would anyone, could someone really be put to death for saying something as obvious as the sun is at the center of the solar system? But it just shows you the changing landscape of like our world and culture over time. So anyway, he had a big role to play, and that was his contribution. Another main important figure that's mentioned in the book too of Western science is Sir Francis Bacon. Sir Francis Bacon lived from 1561 until 1626, and he was a British man, as you could tell, I guess, by his official title there, been knighted in the British Royal Kingdom. But his discovery was this. He was the guy who formulated the steps of the scientific method. And formulated the steps of the scientific method. We'll talk a little bit more in depth about the scientific method, I think, in the second half of this two-part lecture on chapter 12. But probably many of you guys at least have a general familiarity with it from earlier classes that you've taken in your education, like in high school or even sometimes in elementary school. It'll teach us primary lessons in science that go over the scientific method. And sometimes people describe the steps of the method in different number of steps. Our book goes with 5. In general terms, most people remember 3. Like first starting with observation of some event, proceeding to a hypothesis about why that event happens or what the cause was, and then finally testing the hypothesis with some type of experiment which can either give verification or disconfirmation of the hypothesis. So this familiar scientific procedure of observation, hypothesis, and experiment is kind of initially formulated by the ideas and writings of Sir Francis Bacon. So we obviously owe him a huge debt of gratitude for laying down a precise methodology that we could conduct scientific research, and the same overall steps are used in every scientific investigation still today. Noah, you say the trick took advantage of everyone as the mecca of information because no one else could read. I mean, yeah, there was not a lot of literacy in many parts of Western Europe until after the invention of the printing press. So that's somewhat true. I don't know if I would put it in exactly those terms, but there's a truth to that. Let me read some of the book on the same stuff concerning these two important early science figures in the West. So it says here on page 363, prior to the 17th century, the teachings of Christianity, and in particular those of the Catholic Church, were regarded as the final source of truth in Western Europe. Nicholas Copernicus, a Polish astronomer, launched the scientific revolution with his discovery that the sun, not the earth, is the center of the solar system. Many other historians recognize English philosopher and statesman Sir Francis Bacon, who systematized the scientific method as the father of modern science. In his book Novum Organum, Bacon put forth a method based on direct observation for discovering truths about the world. So that classic work kind of contains some of the first detailed descriptions of how the method should be pursued. Oh, you mean the talk about the sale of indulgences, Noah? Yes. It's a little outside of the scope of what we're talking about in a direct sense, but yes, there was the sale of indulgences at one time, a practice later repudiated by the church and even the church authorities. So I think people don't necessarily regard it any longer as having been like one of the high points of ecclesiastical history. But we all know there's been some dark moments in world history for all kinds of reasons. Now, we've talked about some of these early figures of science and what science is in general. The next thing I guess I'll talk to you all about here in the meeting is what are some assumptions that are built into the practice of science. The book goes over some of those. So these are just baseline core assumptions that you kind of have to have for scientific research to exist. And we want to be familiar with them. So let's talk about assumptions behind science, or assumptions of science. Okay, so one of these assumptions, the first one I'll list up there, speculation that Sir Francis Bacon was the real Shakespeare. I've heard rumors about the identity of Shakespeare being questioned, but I had not heard this one about Bacon, so interesting. I'll have to go and research that. Thank you. To the point here, one of the major assumptions of science is a concept that we've actually already looked at before in this class, but it's coming back again, and that is empiricism. Okay, so like a basic assumption of science is the concept of empiricism, and maybe you remember even what it is. Tell me, what's empiricism? It's the view, or it's the belief that most human knowledge comes from some place. Where? Most knowledge comes from where? According to empiricism. What view is this? Let's see, you tell me. Yes, well, observation and And one other little element of it, true enough, but there's a little more to say. Senses, yeah. Well, you say six senses, like the sixth sense with Bruce Willis. It was really five senses. You got sight, taste, touch, hearing, and smell. Some people go talk about proprioception as a possible sixth sense. But anyway, yeah, most knowledge comes from not reason and observation. Rationalism was the one that said most human knowledge comes from just pure ideas and reason. But empiricism is the one that says most of our knowledge comes from five senses and observation. So I'll put it here, just want to make sure we can remember it. Most human knowledge comes from the five senses and observation. So this is a view about where most of our knowledge derives from, and science assumes this is true because science as a practice always initiates from observable data. So science is based on trying to explain things that we can observe and see in the world to give correct explanations or cause-effect relationships between things that we observe and the reasons that they happen. So if you didn't think that you could get knowledge starting from observation and the five senses, then science would have no ability to prove or determine anything. So if you were skeptical about the ability of the five senses to lead us to knowledge, then in that case, you would not be able to believe or trust in science. So science anyway does think that we can get to the knowledge that we are seeking, starting from a place of observation and collecting data through observation. Mateo, you're here, but you're not sure if your message went through at the start of class. I don't know. I don't think it did, Mateo, but not to worry. I see you're here, so good to see you. Not to worry. So empiricism, and here's the way the book describes the same. Empiricism, the belief that our physical senses are the primary source of knowledge, is one of the most basic assumptions of science. Scientists consider the empirical method the only reliable method for obtaining knowledge. Therefore, the more data and observations that scientists accumulate over the generations, the greater is science's ability to correctly explain the workings of nature. Okay, so like some people are skeptical of the ability of our senses and observation to deliver us knowledge. But science, of course, presupposes this, and if it was not possible to gain knowledge from the five senses and observation, then science would be off on the wrong foot. So it's a core baseline assumption of science. Now, continuing from there, what are some others? There's also the assumption of what is called objectivity. And this assumption is all about the following idea that, make sure you can see that's the letter E. Okay, so objectivity. This is the belief or assumption that we can learn about the universe as it really is, not just as it appears to be, but as it objectively is, independently of anyone's own skewed interpretation or bias. So it's the belief that we can learn about the universe as it really is and with no bias. Okay, so the concept of objectivity is oftentimes contrasted with subjectivity, which is kind of like the opposite of that. So I believe that even though we haven't talked about it yet really in the class, it's something that through your life experience and general background knowledge, you probably have some at least overall idea of. So let me work with that and then we'll be more precise in a moment. Tell me, I'm going to give you a sentence here, and I would like you to tell me what your sense of it is. Is it an objective or a subjective statement? So I'll tell you that vanilla is the best ice cream. Now, do you believe that that is an objective or a subjective statement to say this? Vanilla is the best ice cream, I'm telling you that. Is that objective or is it subjective? Let me see what you think about that question. Got two options. You heard the example. Okay, good. Subjective, correct. It's subjective to say that vanilla is the best ice cream. Can I ask a follow-up question? Why do you think it's subjective? You're right, but could you open up on that, expand on it a little bit? Why is it subjective that when I say vanilla is the best ice cream flavor? Why is it subjective? What makes it not objective? So, first question, is it subjective? You say yes, good. Follow-up question, why though? Why do you say that? Well, no, you're saying no evidence to suggest. I don't know about that. I mean, I could give you evidence. I could say it's delicious. It works well with all different toppings, so it's a very neutral flavor, and it's better for putting anything on it. So that's why it's the best flavor. Now I'm giving you an argument. Prue, you say because it's your own opinion, but you do agree with it though. Haha. Okay, yeah. So it's just a person's personal point of view. That's the right way to put it. Yes, Prue. It's something that is just based on my own individual taste and preference, right? So if I think vanilla is the best ice cream and you think chocolate's the best ice cream, neither of us is necessarily like objectively correct because it just depends on individual subjective tastes, preferences, and your own inclinations. Now, what about if I say to you that the Earth is the third planet from the sun? Is this objective or subjective? New example. What would you say about that one? To say that the Earth is the third planet from the sun, is that an objective fact? Or is that just my personal opinion and it's just how I feel today? What do you think? Yes, it's objective, okay? So whether I like it or not, that's just true. It's an objective fact. And what science believes in is that there are objective facts that we can discover, that we're not just all trapped in like our own biases, and that all we can ever explain or express is how things appear to us from our skewed or biased point of view. So science believes in the ability to obtain objective truth, that there is objective truth, that there's an objective world. It existed before you did, it will exist after you do, and there's an objective fact about what it's like. So science believes that we ourselves can discover these objective truths. What would be the point otherwise of doing science if all we thought we were getting at the end was my opinion versus other people's opinions, and we would never actually discover anything that was factually true? So even if there are postmodernists and stuff out there and people who say everything is just opinionated and there's no such thing as objective truth, science doesn't agree with that. So if you're talking to a scientist, at least they assume that there is the ability to obtain and achieve the goal, which is to get to the objective hard truth and not just talk about subjective feelings or personal associations and etc. Okay, so here I'll read from the book. A related assumption underlying modern objectivity: the belief that we can observe and study the physical world out there as an object outside of us with no bias on the part of the scientist or observer. Because the universe is objective and independent of the individual observer, the presumption is that systematic observation will lead to agreement among scientists. So another baseline assumption of science, that there's an objective world, it's independent of your mind, it doesn't just start to exist when you think about it. Sorry, Descartes, but the scientist is not the Cartesian skeptic who says maybe this is all a dream or an illusion. The scientist says, no, there's a real environment out there. It's waiting for you to discover what it's like. And a human being with a reasonable brain can, in fact, discover those things through systematic observation in a community of other objective inquirers. Okay, so that's a second fundamental assumption of science, the assumption that we can learn about the universe as it really is, not just as it seems, and that we can get there with no bias. Okay, so continue going from there. Another basic assumption of science is this assumption of materialism. Now, let me warn you off of a false understanding of this word. We talked about equivocation before, right, guys? Where you have a single word that can have different meanings. There's one meaning of materialism that has nothing to do with science or our topic right here. And probably that's the most dominant interpretation of it that you've heard in the past. So let me make mention of that. Sometimes people say that someone is materialistic if they just care about how they look and about possessions, and they're superficial and shallow. They just care about objects, right? Materialistic. I just want to have the biggest car, nicest house. I don't know, but that's not the kind of materialism that is being defined here as it pertains to science. So it's a totally different concept. So set aside that understanding of the word. to make space for the real scientific meaning that we're looking at here. Materialism in the scientific and philosophical sense is just this. It's the belief that every single thing in the whole universe is made out of physical matter, even including us and our consciousness. So everything's made out of matter, even the mind. Okay. Well, let me put it this way. The belief that okay, so everything in the universe made out of physical matter, including even us and our consciousness. That's materialism. So materialism in the sense that everything is made out of matter, physical material. Here's a quick question. What do you think is the word that's often used to refer to the smallest unit of matter? Okay, you break down physical matter into smaller and smaller pieces, and when you get to the smallest piece, the least little element of matter, what's that little particle often referred to? They call them what? Anybody know a little bit about some physics or just generic, popular physics? The term in reference to the smallest particle of matter. Well, okay, Devin, you say protons, electrons, neutrons, sure. Those are all tiny little particles. But there's a more generic term that's used in sort of summary. Okay, you're saying quarks. Very good there, Paul. I know you therefore understand about the concept of subatomic particles. But traditionally, anyway, before the discovery of those things, the typical common term would have been atom. Yes, atom. So I'll just put that here. Everything's made out of physical matter, and what does this refer to? Atoms. Even us and our consciousness. Now, to touch base with what you wrote there, Paul, fair enough. Yeah, in modern physics, they say there are subatomic particles, like quarks and all that. But if you go back in ancient history, the original term that was used to refer to the smallest thing in physical space was the word atom. In Greek, the word atom actually means uncuttable. Like the prefix a means not. And I guess tome was a type of verb having to do with things. So atom means not cuttable, and that just is supposed to indicate that this is the smallest thing that you cannot further subdivide into smaller parts. So whatever the least unit of matter is, since this is not that I'm not insisting on perfect precision, we can call it the atom for a generic phrase. So in other words, materialism is the assumption that every single thing in the whole universe, not just some things, not just most things, but 100% of all things, is just made out of atoms in various combinations grouped together to form those objects. But the interesting position, or the interesting element of the view, is that it's even us and consciousness that's made out of matter. So some people, obviously, dualists in philosophy they call them, believe that no, the mind is something that's not physical. Like if you believe in the idea of the afterlife or the concept of an immortal soul, then you would not really necessarily believe that consciousness is just purely based on physical matter, because a physical object can be deconstructed into its component parts and destroyed. So if you thought that consciousness was merely just the physical brain and its brain waves and neurological activity, then if the brain was destroyed, as it inevitably will be, dust to dust, as a skeleton later, no brain is there, then the person who's a materialist would say there's no more consciousness, because consciousness is a physical process happening in the brain. So absent a functioning brain, consciousness can't exist. So materialism is kind of like a hard scientific position where there's no such thing as the supernatural, there's no such thing as the soul, there's no such thing as ghosts. All there is matter. There's just atoms, and they are combining in space over time to form different objects. Some of them are quite interesting, like biological organisms that have consciousness. Some of them are not quite as interesting, like maybe an expo marker. But this expo marker and me have something in common. We're just made out of atoms put together in different ways. This is a bundle of atoms grouped together marker-wise. And this is a bundle of atoms grouped together human life form, Homo sapiens wise. But even though I'm much more, I guess, functional and I guess complex than the marker is, everything's just made out of atoms in the end, according to materialism. Now, like I've said, it's an assumption of science. That doesn't mean you have to agree with it, but it is a core assumption of science, and people that are scientific realists hold fast to this assumption. And this is why they reject all claims of paranormal. That's why they reject all ideas of like astral projection or, the immortal soul and all the rest. Paul, you say, with the idea of the atom also present in the Vedic teachings of ancient India, I wonder if there was a PIE root to this idea. Well, yeah. I mean, there's a lot of work in Eastern philosophy that predates the collected writings that we've been able to see that have survived in the West. So yes, I mean, it's certainly true that if you go way back into some of those ancient writings from the Vedas, from the Upanishads, and from other collected sources in the East, that you'll see mention of concepts that are similar to what the Greeks discussed. So I don't want to make it seem as though this is like the exclusive concept of the West, but I'm teaching it in a Western class according to a Western textbook. So that's maybe why I started with the Greeks. Okay, so can you understand materialism? I'll say this too. Materialism is one word for this. There's another word that's used sometimes in philosophy and science that I think is a better word, but it wasn't the one chosen by our textbook, so I'm just being consistent with the book. But to be fair, it's also sometimes labeled physicalism. And I think of this as a better word because it avoids the false equivocation with materialism as like, you just want to have like a super ritzy lifestyle with a bunch of possessions. Physicalism avoids any of those associations because there's no separate meaning of physicalism aside from everything's physical, everything's made out of atoms. But anyway, there you guys go. Hopefully that makes some decent sense. Materialism is another assumption of science because, look, if consciousness and thought was some mysterious thing that's not governed by physical matter and the electrochemical workings of the brain, then it would be like utterly outside the scope of scientific understanding. And that would be like saying, well, science can explain a lot of things, but when it comes to consciousness, just don't touch that. That's something that is, not physical. It's not operating according to physical and natural laws the way other things are. Maybe that's true, and there are arguments that it's true. But anyway, science methodologically assumes that that's false. Okay, so materialism / physicalism, another major assumption of science. Is it depressing to think that consciousness cannot exist in a disembodied form? I don't know. I guess people really want the idea of the immortal soul in the afterlife. So materialism is definitely inconsistent with that. But if you really get deep into science, there's all kinds of mysterious aspects of this universe that raise questions about what we really do know. So I don't think that to have a thoroughgoing scientific perspective on reality necessarily close off all the mysteries and deep puzzling questions about, your identity or your place in the universe. But I digress. So back to this. Another major assumption of science is what is called predictability. Okay, so this assumption is the assumption that the universe overall is orderly and it's predictable. So if that's the case, it implies that established cause-effect relationships will be repeatable and that they will hold forever. Okay, so will be repeatable and will hold forever. Okay, so world, universe. I mean, I probably should have made it say universe. Let me do that because when I write world, even though in philosophy and science it often is supposed to refer to the whole universe, people see world and they think just like the globe, the planet Earth. So anyway, let me modify that if I may. The universe is orderly and predictable, so therefore established cause-effect relationships will be repeatable and they will hold forever. So let me try and explain this through what I hope is a simple enough example. So you see that I'm holding this marker, right? This expo marker in my hand, and just holding it in my grasp at this freestanding height above the table. What I'm going to do in a minute is I'm just going to release my grasp, okay? You understand? I'm just going to let it go. When I do that, what do you predict will happen? I haven't done it yet, so predictions. What do you think? If I let it go right now, what would happen? I wonder what you think. Can you predict the future? What's going to happen if I let it go? This shouldn't be that tough, but let me know. Because it hasn't been dropped or let go, it's still in my hand. So you say then, Preston, it will fall to the floor. Well, it's not above the floor, it's above the table, but yeah, you're saying it's going to fall, correct. And same to you, Devin. And, well, all jokes aside there, Paul, I think that you're being facetious because obviously magic and illusionism is not really like real. So anyway, yeah, you're thinking it'll fall. I'm not going to drop it yet, though. I got more questions. Why do you think it's going to fall? Why? How do you know? I haven't done it yet. Some kind of like psychic? How do you know what's going to happen? I mean, I have not let it go yet. So how can you tell me it's going to fall? What tells you? Why do you have confidence about that? Where's this prediction coming from? Why? Why do you think it's going to fall? Okay, so you're saying Newton told you. I guess this is your shorthand way of saying, oh, it's gravity, right? Or can you be a little more precise? Because I know that you've never talked to Newton. Maybe you've read his books. You say inductive reasoning. Okay, that's good there, Matteo. And Devin, you say because you're holding it. I don't quite understand that, though. I won't be holding it when I release it. And it would float. If it would float, you wouldn't need to hold it. Okay, I guess I understand that, too. You say gravity is a constant in the universe. Okay, Noah. I like all these comments. So, and you say, yes, gravitational pull of the Earth, mass of the marker. Fair enough. Well, let me add to that, because I'm not going to let it go yet. You're telling me, you say it's because of gravity. And Matteo, I like the way you put it too. You're saying it's because of induction, because every other time something like that's happened, we've seen the results. We've seen that the thing falls. But I have a really deep question though. What makes you so confident that gravity is going to keep working? I mean, I know gravity has always exerted its force up till now, but Paul, I mean, that was then. What about now? Why do you think gravity is going to keep working now? Can you tell me that? Like, even though I concede the point that yes, gravity implies that it will fall, how do you know that gravity is permanent? Why doesn't gravity take a break today? Or why doesn't it just today is the last day and as soon as I drop this, gravity stops working? How come you don't think that's going to happen? Yeah, well, I guess you're saying you're currently yet, Devin. I've not yet let it go. All you've experienced is the past up till now. The future is yet to be, isn't it? So what you're saying is you expect I would know if it stopped if I started floating. Yeah, but I'm talking about the future, not what would have happened in the past. So how come, Devin, you don't think that gravity is not going to stop at 1:37 p.m. on April 29th of 2021? How come you don't think that it's going to just stop working as it always did before? You understand me? Paul, you say evidence of the placement of everything in the universe we have ever observed supports the idea that gravity is constant. Correct. But you know, your answer still is of the same form. You keep saying because it's always worked before, because all of the past observation of the world has shown that that's how it works. But how about induction? You guys know that with induction, you have a lot of reasons that establish a very probable conclusion. But no matter how many times we've seen this happen before, I guess we can't absolutely guarantee that it's going to continue the same way. Well, Well, you're not floating now. I understand, Devin. But the question of time is just me arbitrarily stipulating a time. All I'm saying is, relative to the present moment, whenever the present is happening, like in an hour, 2:35 will be the present moment. I could ask you at that time, how come you don't think that gravity will stop working at 2:37? Okay, so there will always be a future ahead of whatever time we are at now. And the question is, why do you think that future is going to have the laws continue to function the same way they did in the past, right? Preston, you say, because I know that the Earth is not losing major amounts of mass, which is the cause of gravity, therefore gravity will not suddenly stop. But Preston, the law of gravity itself, what makes you think that it will not completely just cease to function and none of those rules will apply anymore? What makes you think that that won't happen? Paul, but it's as certain as we can be of anything short of accepting Descartes' ideas that we can't know. Correct. Okay, so let me help you out a little bit. I was just kind of playing a little bit of devil's advocate. And by the way, let's see what happens. As predicted, it did fall. Now, what do you think would happen if I had infinite time? I wish I had infinite time, guys. But if I did, and I could just be here with you forever, wouldn't that be great? And I just dropped this marker over and over again. Do you think it would keep falling to infinity if I had an infinite number of trials? If I did, don't you think it would keep falling? Yes. And so what you guys have revealed in your answers to my philosophically annoying questions is that you think that the laws of nature and physics will never change. So you basically agree with this. You agree with the assumption that the universe is so orderly and predictable that once we have established how a certain thing works, gravity, entropy, inertia, thermodynamics, you name it, once we've understood how those things relate to each other, that they will always work the same way, not just today, not just here and now, but everywhere and for all time. So if we had another closed physical system where we could replicate this same kind of event, say on another planet, and if it had the same kind of physical properties as ours, then we should see the same result of the marker dropping. And that this marker dropping, according to the law of gravity, is something that you assume will always function the same way. That gravity is not just a temporary law, that it's not just something that works for here and now for a limited time only. You've told me, according to your own intuition, that these things will not change. And that's an assumption, isn't it? It's an assumption, but we have to have that assumption, because if we didn't hold that assumption, then we could never make any stable prediction of anything in the universe. So another assumption of science is that the universe is predictable, that when we discover something scientifically, we've secured that knowledge for all time, not that the physical laws of nature are somehow subject to change or subject to alteration, that they're somehow permanently written in to the structure of this universe. So now, Paul, you say, but if you did indeed have infinite time, you would have disproved some other tenets of physics that would then throw the law of gravity into question too. Okay, I don't know. Is the idea of infinite time inconsistent with certain assumptions of physics? Perhaps, but I don't know. The open-ended future is not necessarily inconsistent with those laws. Some people think that the laws of thermodynamics would be contradicted if there was an infinite past to the universe. But having an infinite potential future, I don't think necessarily contradicts that. Anyway, though, it's a separate point, but I'm glad you raised it. And therefore, we have another assumption behind science, that laws and physical laws such as gravity, entropy, inertia, whatever, will hold forever, and they'll be repeatable forever. But yet again, Devin, it is an assumption, because the full future has not been experienced. So if gravity did stop working tomorrow, I know we would all be extremely surprised and shocked, but we assume that that will not happen. Nonetheless, it's not proof, this assumption, because the only proof will happen in the full range of time as future time unfolds, okay? So here's what the book said about it. Predictability. Scientists assume that the universe is orderly and predictable. The universe consists of interconnected causal relationships that can be discovered through systematic observation and inductive reasoning. So there you go. Now, one more assumption behind science, then we'll move to the next part of the notes, is the assumption of what's called unity. Okay, so unity, another major fundamental assumption of science. So the unity assumption is basically that there's an underlying unity to the whole universe, that it's unified in the sense that eventually everything will be able to be explained according to a single set of scientific laws and principles. So Okay, so it's the belief that there is a unity to the whole universe, meaning that everything can be eventually explained according to a single set of scientific laws. All right, now, let me see what you're saying, Matteo. Must the universe have objective identity? Without human observation, objects and their properties are indistinguishable. I don't know if that's really true. I mean, you may be thinking of, I don't know, certain results from quantum physics according to which there is an object that is in superpositions, like a quantum particle or a photon, and it is only when the observation is conducted that it appears to have a position. But prior to that, it seems to be in a superposition of states. So maybe you, I don't know, Matteo, if I'm speaking to your own knowledge here, but some people that think about quantum physics then wonder about things like, when there's no observer, what's the status of the objective world? Because it would seem that observation, some people, causes the wave function to collapse, resulting in the determinate position of the particle. But without getting too far into the very subtle details of quantum theory, there are other interpretations of the quantum experiments, like the double slit experiment. Some people hold the many worlds hypothesis of Everett. And according to that hypothesis, there is no wave function collapse because there's infinite universes where every different outcome does in fact happen. But, you know, maybe we don't need to get into so much of those obscure details, but I take the point, and it's a heady comment that you've made, Matteo. Albert Einstein did believe that the universe has objective identity despite the findings of quantum physics. Famously, he said to some of those quantum physicists, do you really think that the moon is only there when you look at it? And stuff like that, which some would argue is an implication of at least one interpretation of quantum. But I'm going to go back to this, if that's okay. The superposition, that's pretty silly. Come on, funny though. I've never heard that one. To the unity claim. The view is that the whole universe could eventually be explained according to a single, elegant set of scientific laws. Since we live in one universe, the belief is that it should work according to one set of rules. But really, to be fair, this ambition of science to get to that single unified set of laws, it's not yet been achieved. That's like the holy grail of science in a way, to get to what they call GUT, Grand Unified Theory. Right now, we're not there because instead of having a grand unified theory, we have two different, somewhat inconsistent sets of principles to describe the operations of macro scale events and micro scale events. So for the tiniest micro scales of reality, we have quantum physics, and that is extremely predictive about the behavior of these quantum particles. But to describe the macroscopic levels of reality on the larger scale, we have the electrodynamics of moving bodies from Albert Einstein and the theory of relativity. And there's actually some inconsistencies between quantum theory and relativity. So eventually we hope to build like a bridge between the two fields so that we can have one elegant set of principles that describes both the large and small scales of the universe. It's not yet been achieved, but scientists hold it as a sort of almost tenet of faith that we can get there, because reason just tells you that if you live in one universe, shouldn't it be that everything operates according to one unified set of laws? And in the book they say this. Associated with the belief in predictability is the assumption that there is an underlying unity of the universe, a unified dynamic structure that is present in all phenomena. These unified structures can be translated into scientific laws that are universally applicable. Indeed, Einstein devoted considerable effort during his lifetime in search of a grand unified theory, a search that is still to this date unfulfilled. Okay, so then, having talked about some of the core assumptions behind science, we're now going to speak about what are considered certain limitations of science. These could be thought of as things that science is bound to assume, but that cannot yet be proven, or perhaps just limitations in terms of what it can prove or discover. So, limitations of science. What are the limits, the boundaries of science itself? Okay, now some of these limitations mentioned in the book, I thought were quite philosophical and maybe almost a little too esoteric for many real practicing scientists. But anyway, it's worth pointing them out. So one of the stated limitations is that science obviously assumes that the external world exists and it's not all a dream or, simulation, which is an assumption that is, I think, obvious to make, but it can't be absolutely proven. So anyway, there you go, that's one. Science assumes that the external world exists. Which cannot be absolutely proven. I mean, it's probably true, obviously. How weird would it be to find out that none of this is real? But it's an assumption science has to make. Obviously, if you didn't think there was an external world, if you followed Descartes' suggestion that it's possible for everything around you to be a big dream, or like you're living in the Matrix or something, if you really thought that, then what would be the point of doing science? Because whatever you would be discovering scientifically wouldn't be about any real environment. It would be about the simulation itself. It would be like Mario and the Mario Brothers trying to perform scientific experiments on those mushrooms and power plants and stuff, and trying to determine what their properties are. There would be no real knowledge he could discover because he's not in a real world. He's in like a simulated environment, a false environment. So of course science assumes that we are in the midst of the real world and that it's externally real and it's not just a projection of your own thought or some kind of dream that's been given to you by another source. And obviously, science wants to explain the world and how it works and what the cause-effect relationships are, so it assumes this world is real. But can it absolutely be proven? I mean, I don't want to go too far down into the world of skeptical doubts that Descartes raises. But obviously, you can't quite prove it, because suppose this was a simulation. If it was a very good simulation, then what would it look like? Exactly like this. It would be indiscernible from the reality that one could have experienced. So I guess, given the possibility of an ultra-realistic simulation of external reality, we're limited with the assumption that it does exist. But I don't find this to be the difficult, most problematic assumption science makes, because the only people who would find fault with it would be people that are really into like the idea of solipsism or skepticism, which I don't think most anybody is. Even though it's funny, everyone's postmodern, everyone's like, oh, I've got my own truth, I've got my own truth. But then you tell them about Descartes and they're like, no, there's definitely an external world. It's not just made up by me. Anyway, it's just kind of funny. So that's one assumption of science. And then another one is that science can only study and analyze things that are observable. So if there was anything that's not observable, then that would permanently remain outside the scope of a scientific analysis. And that could be seen as a limit to some people. So another limitation, science can only study what is observable. Okay, so science begins with the observation of data and facts in the world, and then we proceed to try and explain how those things work. Yeah, and that's right, Paul. What is observable in some cases may not yet be known. I mean, the atom was a theoretical concept for thousands of years, and now we've developed electron microscopes so that for the first time we can actually look at these tiny little particles. They were posited as having to exist by earlier generations of scientists. Now we have the tools of observation to make what was formerly a postulate something that we can actually see. Cloud chambers would be another example where the indirect effect of a particle on its environment in the cloud chamber gives us an indirect method of observing it. So yeah, some things become observable through the introduction of extraordinary new technologies. Take the Hubble telescope, for example, which can look at the deep field of space and see galaxy superclusters that are billions of light years away. Yeah, so I totally agree with that. But the only point here is that you could see it as a limit in a way, because if there is anything that's not observable, okay, so let's go into like the supernatural, the spiritual, the paranormal. If there's a soul, if there's an afterlife, if there's any such thing as the supernatural realm, then that by definition is not observable, because a soul is not a physical object like, a bone or an organ of the body. So in that case, we would say that that stuff can never be understood scientifically. A scientist is probably going to be a skeptic about it and say, well, if it's not observable, it's probably not even real. But many of us might find fault with that and say there's got to be certain things that we are either not capable of observing or at least not capable of observing as of today. Even scientifically, there are some problems here, because there's one issue with the expansion of all matter in the universe. So scientists see that we are living in a universe that's rapidly expanding, meaning that all the matter is being pushed further and further away from all the other matter. And it's creating a universe that's gradually less and less matter dense. In time, people think this could lead to the total cold death of the universe if it continues to expand, because at some point in time, everything will be so far away from everything else that there'll be no ability for anything to generate heat or even to coalesce into like macroscopic objects. Well, what's driving this outward expansion of all material? It's not really explicable even according to the forces that generated the Big Bang, if that did happen, because gravity is a contracting force. So why is it that there's something that's overwhelming all these attractive forces and causing everything to push outward? In fact, it's even accelerating, so that's hard to explain too. Some people think it has to do with the concept of dark matter. So this is a postulate that some physicists today have, that dark matter somehow, which is being dark outside the realm of direct observation, that it's driving the outward expansion of all the material. But that's not observable, and so it's going to be a difficult task for scientists to reconcile the unobservable nature of so-called dark matter with the hypotheses that they're trying to explain on the basis of it. So anyway, you say you're anxious for Webb. Now I don't know what you mean, but maybe you'll tell me, or otherwise I'll just have to think about it later. Okay, so and then one other thing is that some people also see the predictability assumption as a limitation itself. As I was sort of trying to help you understand with the marker example and all of that, the assumption that the physical laws, oh, there you go, I get it. New Space Telescope, cool. Anyway, about these physical laws like gravity and so on, the assumption that they will always work, they will never change, like Devin, what you were saying earlier, like if I drop it at 137 or 237 or any time in the future, it's always going to work the same way, even though we haven't been into that future just yet. This assumption, some people like David Hume, the classical British philosopher of the 1800s, or 1700s rather, some of those guys said, how can you really be so assured of predictability? You know, the future is as yet to be experienced, and the operation of these natural laws has only been observed heretofore till the present moment. Can we assure ourselves that natural laws never vary and that they remain permanent in the way they function? I guess we can't absolutely guarantee it, but some see that as a limitation. We're helping ourselves to an assumption that we can't prove. All right, then. So moving on from the limitations of science, the book next talks about different attitudes people can and do have about the relationship between science and religion. Okay, so probably many of us have heard that in some general way, science and religion don't easily fit together, that they may contradict each other, or that if some people, you know, harbor very strict religious views, that they might reject certain scientific claims, or vice versa. If this person's very heavily steeped in the scientific realism of the scientific community, that they might reject certain religious claims. But what are the different viewpoints and perspectives that people have about, you know, the relationship of science and religion? Well, there's basically four, so I'm going to put them here on the board. So 4 views about the relation of science and religion. Okay, so one of them, first one to mention here, yeah, WebMD is a little scary, I guess. You can, if you're a hypochondriac, don't look at WebMD. But 4 views about the relation of science and religion. The first one would be the idea that science takes priority over religion if the two things conflict. Okay, so that's one attitude, one view. It's not the only one, but that's the first one mentioned, that science takes priority over religion when the two conflict. Okay, so now science and religion sometimes appear to disagree. Not to worry, good to see you back there, Jake. Sorry to hear that, Noah. I know it's a totally random thing to say, but if you do have shingles, just relax and calm down, because I think usually it comes from stress. But to the point here, when people see science and religion disagree about whatever, okay, let me give you some examples. Creationism versus evolution. Did God create us in his image right away, so there was no long process of gradual change from like great apes to the Homo sapiens that we are now? If you're a certain type of religious person, you would deny the claims of evolution. And you know, if you're scientifically minded follower of the theory of evolution, then you would say no, creationism is false. A person who holds this view is going to side with the scientific account when there are these discrepancies. Is the biblical flood something that really happened? According to certain scriptures, yes. According to certain scientific analyses, no. And if there is such a disagreement or discrepancy, a person who harbors this position is going to side with the scientific account. Cosmology. How long did it take for the mankind to appear in the universe? According to the scriptures in the Old Testament, God created everything in 7 days, and on the seventh day he rested. But according to science, this is far from true, because it took billions of years, they say, for stars to coalesce and for planets to form, and even longer for primitive little single cellular life forms to evolve into vertebrate life forms, mammalian, eventually Homo sapiens. So there's a lot of claims where we can see a straight up disagreement between some religious views, some scientific views. Did Adam and Eve live? According to religion, yes. According to science, this is just a myth. So when these conflicts arise, anybody who holds this view is going to favor the scientific account and reject the religious one. In the book, they use the term or the verb trumps. Science trumps religion when the two conflict. We just had President Trump, and so I didn't want you to maybe draw the wrong association with the name, but the word trump can actually be and is a verb. When something trumps something else, then it supersedes the other thing, and it's supposed to be taken to be more important or to be prioritized over the other. So to avoid any false or misleading associations, I'm just giving a slight synonymous description that science takes priority over religion when the two conflict. Now, Paul, we'll have a chance to talk about a view just like that, because there's 3 more to go, so you're going to have good company. Next. Game of telephone versus science? I don't know. Yeah, you lost me a little bit there, but it's okay. Here's the next one. It's just the reverse. The flip side, that religion takes priority over science when the two conflict. So in the same way, you can have a different person with a different point of view who sees these conflicts but says, you know what, I'm going with religion and I'm rejecting the scientific account. And some people will do that, obviously. Some people will say, if religion tells me that human beings and this planet are like 5,000 years old, and people talk about dinosaurs that are millions of years old in science, I just reject that. I think somehow these are false claims, and I'm going to stick with the religious view. So obviously you guys know there are these different attitudes. We're all different. Some people have their own different approach to life. Some people are going to be a thoroughgoing, traditional adherent to a religion. And when science comes into conflict with those views, they just set the scientific account aside and reject it. And of course, there are some that hold the other way of looking at it. And the last two so here are number 1 and 2. Let me create some room. 3 and 4 try to not necessarily side with one or the other, but they try to get away from the appearance of conflict itself. So the third one is to say that science and religion deal with different topics, so they actually don't conflict because they're in their different lanes. They're dealing with different topics, so they don't step over each other's bounds. So that's the third view. Okay, so to some people, the idea is, well, religion and science, actually, there's no contradiction because they're not even concerned with the same stuff. You might think that religion is where you turn to when you want to learn about moral questions or about a subjective spiritual connection to a divine being. But when you want to learn about like cause-effect relationships, material processes, how things work, that's where you turn to science. So if science is all about like an objective physical reality and religion is all about like a subjective, valuated, kind of morally laden reality, then maybe they're not really contradicting each other. The only problem, though, with this view is that it's hard to at least ignore the appearance of conflict when you look at just some of the claims that both fields make. I mean, religion talks about the origin of man and the origin of the universe and the timeline of these things happening. And so does science. And they certainly, at least on a straightforward reading of both, they're not saying the same thing. So we can try to relegate them into their own separate domains or worlds, but they're both talking about human beings and their position in this universe. So it's kind of hard to exactly eliminate at least the feeling that there's some disagreements between them. Well, anyway, there's a fourth option. Paul, this fourth one kind of sounds like what I think you're talking about in your comment. The fourth one is to say that science and religion are compatible. So in that way, it's not that they're onto different topics, but that if you interpret them correctly, they'll somehow agree. So that's science and religion are compatible. So this is the view that a person has when they think that if you somehow like just finesse the interpretation of the religious scriptures the right way, they will come into alignment with whatever the scientists are discovering. So, okay, let me give you an example. Scientists say that the universe and mankind were not created in 7 days, that it took billions and billions of years just for the planet Earth to emerge, and then billions more years for life on Earth to evolve into the current human form that we have. But if you read in the Old Testament, it does say that God created everything in 7 days, and on the seventh day he rested. So that looks like a contradiction, but somebody might just say this. What do you think I'm going to say? Oh, well, you know what? You're taking it too literally. In the Bible, it says 7 days, sure. But that doesn't necessarily have to refer to a typical 24-hour day as like we experience on this planet. It could be like a day of indeterminate extent. You know, it's an epoch of time, as you're putting it, Paul, that is like a day in the arbitrarily designated amount of time that God would call a day. So 7 days of creation could be billions and billions of years. Or what about the difference between creationism and evolution? Someone says God created us in his image. And Darwin says, no, he didn't, because we came from, a gradual series of changes through natural selection. Maybe a person could say, oh, yeah, they look like those two things disagree, but maybe God created the process of natural selection, knowing what its ultimate outcome would be, knowing that it would result in the beings that are designed in his image. So there are all these ways of trying to make the two things compatible. But, and I know what you mean, Paul, you're thinking, well, if you're writing in time period and if these divine revelations are being given to human beings at a certain time in history, which are pre-modern times, let's make it something that makes sense in the mind and the life and the language of those people. So that's certainly one way to go. But as I'm trying to show like rational balance and criticism of everything, you can also say of this that it's somewhat ad hoc, okay? And here's what I mean by that. Ad hoc means that you're just inventing a justification after the fact. So, right, take even the question of whether the Earth's at the center of the cosmos or not. If you say, oh, well, maybe we meant all along that it was not in the middle, and now we're just reinterpreting the statements, or I don't know, the question that I just raised or the example I just raised. In the Bible, it says 7 days, but let's change it to millions and billions of years because scientists are discovering things using carbon dating about like fossilized remains of dinosaurs and the age of the Earth. And all this fact that science is giving us seems to contradict the literal reading of those words. So let's just change the interpretation so that it fits whatever is being discovered. I put it like this. Say that somebody fires an arrow at the side of a barn and there's just no aim. They just shoot it at the side of the barn and it lands somewhere. And then they walk up to it and they draw a bullseye around it. Does this mean that they're an expert marksman because they hit the bullseye? No, they just drew the bullseye wherever the arrow happened to land. And so you can argue that, well, science comes out with like a new theoretical discovery that, whatever, the universe is billions of years old or something. And now the religious community says, well, let's make it so that we can agree with that. So let's make it so that whatever we were saying before already says the same thing. And now we just kind of update the interpretation and make it less traditional, less literal, less fundamental, so as to accommodate the developing scientific knowledge that's coming out from the scientific community. So you could argue that maybe any attempt to reinterpret religious scriptures to bring them into compatibility with science is in a way intellectually dishonest. But I don't know. I mean, at the end of the day, if you believe in these things, you probably are going to have to find some way to reconcile them unless you want to straight up reject one over the other, which is kind of hard to do. If you're using all this technology, you've got to have some respect for science. Obviously, people are not just playing a guessing game when we were able to divine, the splitting of an atom, a nuclear weapon, a computer. So I have a lot of respect for science, and I think that it's pretty objectively correct because of the success that we've had in developing technology. If science was just like a bunch of weird alchemy where people didn't really know what they were doing and it was pseudoscientific and disconnected from objective fact, then we would never be able to use our scientific knowledge to control reality so much like we have. So I don't know. Those are my thoughts anyway. And you say, Paul, for me, if a scientist says there's no God, then I disagree. But if a priest says science is wrong, I disagree as well. Well, I think that's a good, fair, balanced way to look at reality. I mean, to me, there are arguments for the existence of God that are compelling and that are worthy of attention. In my own mind, I think I have a long time in life to think these things over. And if there really is a God, I trust and believe that he would be good and that he would be righteous, so that he wouldn't punish people who are simply trying to pursue knowledge, as long as they have not acted in a morally inappropriate way. So I feel like I have plenty of time to continue to, I don't know, reflect and ponder on the questions, the divine mysteries of religion and stuff. I'm maybe a little more secular by nature because I grew up in the household of a aerospace engineer and a physicist. But I have a certain kind of respect and interest in religion, and I've studied it historically, so I think it's quite fascinating. But anyway then, guys, we're reaching the end of today's meeting. We're going to come back on Tuesday, and we'll continue, and we'll finish the remaining part of Chapter 12. So yeah, that's, I think, a good breaking off point. When we come back, we'll start talking about the scientific method. We'll talk about all the steps that it has. Then we'll talk about how to evaluate scientific hypotheses, and we'll speak a little bit about pseudoscience. Yeah. Well, I don't know, Noah. I'm not trying to flex or anything. But, you know, if a person wanted to flex, I think being intelligent would be the best way to do it, rather than to sort of just be like, I have the coolest clothes. But I have some nice clothes, too, and a nice watch. Hey, Mateo, objects might not exist individually and separately from the rest of the universe. A tree that burns doesn't stop existing because it's nothing more than some matter. Well, let me think about what you're saying. Objects might not exist individually and separately from the rest of the universe. Well, okay, because like the tree then just turns into other forms of matter. Is that what you kind of mean? The ash that the tree has now become gets scattered by the winds and, you know, decomposes into other things, eventually maybe forming new objects later or merging with the soil and regenerating new things. It does become a different state of matter. And what physicalism and materialism say is that everything's just made out of atoms. You, right now, are just a bunch of atoms grouped in a certain particular way. Does this mean that there's no such thing as objects? I mean, that's a philosophical argument. I've heard one guy make that argument, Peter Unger. He said that because no object maintains its physical identity, because atoms are constantly being lost and gained, that we can't ever say of a given object what its physical nature is, and that the atoms are the only real thing. But I think that's a little too revisionary of common sense, because we do talk about medium-sized physical objects all the time, like this thermos, like my watch, like me, like my glasses. So maybe the precision in terms of their material nature doesn't have to be that they retain every single part throughout all of time. Otherwise, then we would say no objects exist. And that would be a weird thing to say, because here you and I are, and we're two different people. So it seems like we're two different objects, at least. You know, I wonder about that. Last thing I'll say, since you're getting me into some philosophical discussion, why? So here's one of the things that makes me kind of believe in like religion and God a little bit. Why should, if everything's just matter, why should there be different consciousnesses? You know, like this marker, this other marker. It's not like, I mean, they're two separate physical objects, but how can my consciousness be different from yours if we're all just a bundle of atoms separated in space? It would be hard to understand the emergence of a personal identity from a universe that has no consciousness at the beginning. But then again, I digress. I mean, that's what neuroscience tells us, that the brain is the source of consciousness, and it's a highly complex physical object that's evolved. But anyway, I gotta go though, guys. I do have to hold in my next meeting. But I like the discussion, and I appreciate all your guys' comments and thoughts. So let me end this for now. Not to worry, we'll be back after the weekend. But let me see in the comments that you're good to go. I don't want to close while we're still talking. So is everything fine? Mateo, yeah, there's literature about how maybe Descartes was too generous in assuming the existence of the self. I don't know. Yeah, thanks so much, Preston. Take care. Thanks everybody else here for having a nice meeting, some good comments. I'll see you guys back on Tuesday. If you need anything in the meantime, please email me and I'll be in touch. I should be ready to tell you guys about upcoming assignments soon, but I'm gonna let you work on homework 3 until after the weekend. All right then, have a good one, and I'll see you then soon. Bye-bye.